So let's go over a summary of what we've talked about today. The P prime NL shear. This provides the incipient cross shear flanking updrafts, and that's going to be further aided by stretching effects, and that's in reference to P prime NL FE. So we initially have that horizontal vorticity, it's tilted into the vertical, get new updrafts form along the flanks of the initial updraft, then stretching processes take place beneath those updrafts that are going to be associated with further amplification of the updraft, while stretching of the background vertical vorticity that has been redistributed to the vertical through the initial updraft will further support P prime NL shear becoming negative, since this is going to be related to the vertical vorticity, and we have this feedback process then evolve. For a straight hodograph, what we see are symmetric updraft enhancements to the right and left of the shear vector, effectively talking about these mirror image storms, as we talked about, as the horizontal vorticity is tilted into the vertical. And then we get this feedback process that gets going, where we have P prime NL shear become relevant once we have vertical vorticity, and P prime NL FE plays a role once we get those new updrafts form. We're effectively drawing more air in from the low levels. Upward, updraft strengthens, vertical vorticity increases, P prime NL becomes even more negative, etc. And this is all because of, from, I should say, the interaction of the updraft with a vertically sheared environment. In addition to what we're having from the deviations from hydrostatic balance associated with CAPE. So once we have just enough CAPE present to get an updraft, and that updraft is becoming superimposed with the vertically sheared environment, then all of a sudden all these dynamical terms become relevant once we get the rotating updraft, and we get dynamical lifting take place beyond that associated with the deviations from hydrostatic balance represented by CAPE. So effectively dynamically induced lifting from the fact that we have a rotating updraft and all of these feedback processes occurring concurrently. And this is what makes supercell storms with rotating updrafts stronger than pulse convective storms, where there's no rotating updraft that typically involve in a much weaker shear environment, since it's that rotating updraft and all of these processes that are redistributing the horizontal vorticity from the vertically sheared environment that are going to be resulted with this additional dynamical lifting beyond that associated with deviations from hydrostatic balance. And we're going to show how we even get additional dynamical lifting occurring from the linear term next time in class, and that will be something we'll be discussing for the next class.